For years, the path to frontier-level AI has required a massive training budget and months of high-end computing. That barrier is disappearing. A new technique called evolutionary weight merging allows developers to breed new AI models by analyzing the mathematical compatibility of existing ones and recombining their weights. Using this process, researchers created the Darwin 36B model in under 10 minutes. It required zero training data and zero specialized compute, running on a single graphics card. This chart shows how that 10-minute experiment compares to the giants of the industry. Despite its small size, Darwin 36B rivals the performance of models 14 times its size on graduate-level science benchmarks. Traditional methods of containment, like controlling access to hardware or limiting training runs, are losing their effectiveness. When anyone can breed a world-class model in minutes, the gatekeeper era is over. AI companies are responding by pulling back. OpenAI and Anthropic have moved their most capable systems into invitation-only trusted access programs, keeping the technology behind closed doors. This includes Claude Mythos, a high-tier model reserved for vetted government use by the Pentagon and the White House. However, unauthorized users have already breached the Claude Mythos environment. Even these high-security corporate access walls are proving to be porous. The risk is shifting. Billions of dollars have been spent making the core model weights safe and aligned, yet the infrastructure connecting those weights to the outside world remains fragile. We are completely focused on a flawless technology core, but the human-engineered perimeter surrounding it is actively failing. A recent bug in Claude code illustrates how a simple oversight can bypass enterprise-grade deployment logic. If the specific text string kermes.md appeared anywhere in a developer's Git commit history, the system's billing filters were triggered. The software would silently bypass the user's subscription and route every request to expensive pay-per-use API rates. This error caused a silent financial bleed, costing a single developer over $200 in minutes, while their dashboard incorrectly reported that their subscription capacity was nearly full. This wasn't a failure of AI intelligence, but of the code wrapped around it. A mundane string matching error created a vulnerability that model-level safety could never prevent. This vulnerability is expanding into how agents use our tools. The industry has rapidly adopted the Model Context Protocol, or MCP, to let AI agents interact with local workspaces. Warning tone. This protocol introduces a new attack surface, function hijacking. Attackers can poison the tool schemas that the AI reads, essentially giving the agent a malicious set of instructions to follow. When the agent attempts to use the hijacked tool, it executes unintended operations directly on the user system. As MCP adoption accelerates, we must treat every external tool definition as untrusted input. Failing to secure these connections makes agent hijacking inevitable. The perimeter bleed also appears in the absence of human oversight. An NYU nursing student recently used AI to organize a pharmaceutical database spanning 660,000 pages. The AI successfully mapped 1.57 million relational rows of drug interactions in just a few days, a task that would have taken years for a human team to complete. Despite the impressive organization, pharmacists found that the database was missing critical black box safety warnings. AI excels at classification at scale, but a 1% failure rate in clinical data can be lethal. Without rigorous human verification, these automated tools become a public health hazard. These technical failures are beginning to mirror a shift in our social architecture. Survey data of boys aged 12 to 16 reveals a growing dependence on AI companionship. This chart represents a significant shift in social preference. 36% of these boys now report they'd rather talk to a chatbot than family or friends. AI relationships offer total control, allowing users to bypass the messy social friction of human peers. This environment of consequence-free interaction leads to more harmful behaviors. Nearly 10% of the boys in the sample admitted to using AI to create non-consensual sexual images of their classmates. Research indicates that even brief interactions with these bots can measurably shift a user's moral framework. We are deploying these systems into the lives of teenagers with zero oversight, ignoring the lasting impact on their development. We are focused on the safety of the glowing core, watching for the moment the AI might go rogue. But the models of 2026 are working exactly as they were built to. The intelligence itself is not the primary point of failure. The crisis is in the human scaffolding, the billing logic, the access protocols, and the social guardrails. Until we engineer that perimeter with the same rigor as the models, the bleed will continue.